Hello, welcome to this lesson of our study of ordinary differential equations or differential equations. Okay, so in this series of lessons, we are actually doing what we mean by ordinary differential equations. Okay, so we'll take our time and go through partial differential equations as well. Okay, so if you have not subscribed to my channel, kindly subscribe. So in this particular lesson, we will go through how to find a differential equation for a given general solution. Okay, I hope you understand or you got what I said. Okay, so we just going through the ways or the methods or how you be able to derive a particular differential equation given its general solution. Okay, so kindly bear in mind that it's not its particular solution but rather its general solution. Okay, so let's look at this. Find the differential equation whose general solution is this. So the general solution is giving us how do you call it, a straight line. Okay, y equals mx. Okay, y equals mx. So this is your general solution. Now to find a differential equation that corresponds to this, and here we forgot to write something. M is a constant. Okay, m is a constant. Okay, so it's just a constant like that. Okay, so one thing we should know is that given the general solution like this, okay, so you count the number of constants in here. The constant here is just m, and you have only one constant. Okay, so to solve this, what you do is, the moment you know the number of constants, and you know that the differential equation you get should be the order of the number of constants. So the number of constants here is just 1. Okay, so it means our differential equation should be a first order differential equation. Okay, so that is the first guide we should get, or the first point you should know. So the constant here is just 1. So, and when the constant is 1, the original general solution, you name it as one of the equations you use. Then we said it's just one constant, so you differentiate it to 1. Okay, so you differentiate the general solution once, so you differentiate dy dx, and you differentiate this once, you get what? M. And name this equation 2. So when you have only one constant, you use 2 equations. That is the main general solution given to you, and then the first derivative. When you have only one, that is only one constant, it means first of all you said you have to get a first order ODE, and the second point is that you need 2 equations to find this or to solve this, and that the one of the equations is the general solution given, and the other one is the first derivative of the general solution given. Okay, this is what happens when you have only one constant. Okay, now you know that m is equal to, so from this equation 2, m will be simply equal to dy dx. Okay, so you go back to equation 1 and put dy dx in place of wherever we see m. So we have in equation 1 y is equal to mx, so I put m equals dy dx there, so I have dy dx times x. Okay, so this simply means that I have y equals x. Okay, y is equal to x dy dx, and this is just a differential equation. Okay, so you can actually manipulate this and say y minus x dy dx equals 0, or someone may divide through by negative and have x dy dx minus y is equal to 0. This or that is correct. Okay, this or that. How you get this? So this is very simple, right? So let's look at the second one. The second one is find the differential equation with the general solution given us this. Okay, so where a and b are constants. Okay, I'm really sorry I didn't bring them, but all the variables here, all the parameters, that's the a and b's and the c's, are all constant. They are constants. Okay, so in the question, some of the question would indicate that. Okay, but know that y is a function of only x. We are dealing with ordinary differential equations. Okay, so therefore when we have we have a and b to be the 2 constants, so it means our differential equation should be a second order differential equation, and that we have how many constants? We said two constants, which means in order to eliminate the two constants, so the idea, let me find time and talk about this. The whole idea here behind this is that you are trying to eliminate the constants here. That is all. Okay, so the question can be eliminate the constants a and b without necessarily asking you to find a differential equation. Okay, then what you are supposed to do is simply find a differential equation. So what will happen here is that since we know that we need a second order, or the differential equation be a second order, sorry, the order didn't come well. Okay, so it's actually second order. Okay, so we need a second order. Now what will happen is that we said we first pick y to be equal to a sine of x plus b to be your first equation 1. Then since we have two constants, we need two equations in addition to this. So we need three equations, and the first one is always the general solution given. Okay, then dy dx will be equal to a cos of x plus b. I hope you understand this. And obviously we need the second order, and this is the reason, or this is what will give us the second order. Okay, when differentiate a cos this with respect to x, you get minus a sine into x plus b, so you call this equation 2 and you call this equation 3. Okay, but so from 2, you say equation 2 is d squared y dx squared is equal to minus a sine x plus b, and from equation 1 we have y being equal to a sine x plus b to be our solution. So you look through the first equation, that is the equation 1, the solution, realize that the whole of a sine x plus b is actually equal to y. So you come back to the second derivative. Wherever you see a sine x plus b, you put y there. So the second derivative, you have d squared y dx squared is equal to minus a sine x plus b, and a sine x plus b we said is y, so you put y there, and then you have d squared y dx squared plus y is equal to 0, and this becomes your ODE, because at the end we've been able to eliminate both a and b. Okay, this equation does not contain any a or b. Here, put it in mind that it's not necessarily finding the value for a and b, please. You are just eliminating them. Okay, all right, so let's go to the next one. I think that one is some way tedious than the others. Okay, so you have your general solution being c1 e to the negative 2s, like that. Okay, so what happened is, first of all, we said you name your first equation. Okay, let me name it here since we have it. So this is an equation 1. From the question, we name the main general solution to be an equation 1. Then we have how many constants? You have two constants, c1 and c2. It means we need two derivatives. Okay, so we need the first order derivative and then we need a second order derivative, meaning that our differential equation should be a second order differential equation. Now go to the last one here. Indeed, this one is a second order differential equation. Okay, so always check these, and then since it's a second order, we need three equations, and the three equations, one is the general solution given us as your your working solution, and then the other two equations will be the derivatives you get. Okay, so dy dx, you first find dy dx, and dy dx is actually equal to minus 2c1 e to the negative 2 e to the negative 2x. Okay, e to the negative 2x, then plus 3c2 e to the 3x. I hope you know how to differentiate this. Now you find d squared y dx squared, okay, should be equal to positive 4. Okay, so we have 4c1 e to the negative 2x plus 9c2 e to the 3x, and this is our second equation. Okay, and this is our third equation. So what will happen is that you try to eliminate the constants here. So it's up to you to know the method you will use. Okay, so the first thing we should do here is note these equations very well. I'm coming to write something here. The first thing you should do here is you multiply equation 2 by, or let's say equation, let's see this, equation 1 by negative 4. So negative 4 times equation 1. Okay, equation 1. And what would that give us? So you come to equation 1, the main general solution. So you multiply negative 4 throughout, and you have negative 4y being equal to negative 4c1 e to the negative 2x minus 4c2 e to the 3x, right? Okay, then you add this to, so it should be minus 4 times equation 1 plus equation 3. Okay, so what you do is you pick equation 1, multiply by negative 4, then you add it to equation 3. So plus equation 3 give us d squared y, okay, d squared y ds squared being equal to, is it plus or minus? Okay, being equal to 4c1 e to the negative 2x and plus 9c2 e to the 3x. So this was equation 3. So you multiply equation 1 by negative 4, then you add it to this. When you add the left side of both equations, you get d squared y ds squared plus negative 4y, which will be minus 4y, and then you add the right side of the equations. Now realize that this is minus, this is plus. When I add them, I get 0. Okay, so that one will give me 0, and when I add these and these, negative 4 plus 4, that will give me 5c2 e to the 3x. Then call this equation 4. Okay, so actually we used equation 1 and 3 to get 4, so not necessarily that we need 4 equations, but after getting our 3 equations, you can use any of the 2 to construct other equations. Okay, so now you go to equation 2 and equation 3 again. So you multiply 2 times equation, let me write this word, equation 2, then plus equation 3. So we are using equation 1 and 2 in addition to equation 1 plus, you did something to equation 1, then added it to equation 3, and we are doing same to equation 2, add it to equation 3 and see what will happen. Okay, now I go to equation 2. What is equation 2? Is this one, and I multiply it by 2. Okay, both sides, meaning that I have 2 dy ds. Sorry, where is it? Okay, I have 2 dy dx, that is at the left side, and at the right side I'll have minus 4c1 e to the negative 2x plus, when I multiply 3c2 by 2, I have 6c2 e to the 3x. Okay, then we are saying plus equation 3, and equation 3 is d squared y ds squared equals 4c1 e to the negative 2c, x plus 9c2 e to the 3x. Okay, so when you add these two, what you have is d squared y ds squared, plus 2 dy dx is equal to, this is negative, this is positive. When I add, I get 0. Now I have 15c2 e to the 3x, and this is equation 5. Okay, because when you come to the previous one, you have equation 4 here. Now equation 4 has something like this: 5 times C2 of that. Okay, now let's go to equation 5 and see. This is 15 of that, but 15 can be rewritten in terms of 5 times something. Okay, so if I clean 15 and write it like 3 times, okay, 3 times 5, and that is 15. So I have 5 C2 like that. Okay, so 3 times 5 will give me 15. So what is 5 C2 e to the power 3s? 5 C2 e to the power 3s is equal to this in equation 4. So from equation 4, this is 5 C2. Okay, so wherever I see 5 times C2 e to the power 3s, the whole of this thing in equation 5, I put this whole expression with the yellow square there, because 5 times C2 e to the power 3s is the same as that expression. Okay, so in place of this side, I just come and put, I just come and put the squared y ds squared minus 4y. Okay, that is equal to 5C2 e to the power 3x. So you can see that is very simple. So I have from equation, I have the squared y ds squared. Okay, the squared y ds squared from equation 5 minus 4y. Is it minus 4y? No. Let me go and check. Okay, plus 2 dy dx. Okay, so plus 2 dy dx, and this should be equal to 3 times 5C2 e to the power 3s. And we said that 5C2 e to the power 3s is the same as the squared y ds squared minus 4y from equation 4. Okay, so therefore I can simplify this because there is no constant here anymore. So I have the squared y ds squared plus 2 dy dx. Okay, 2 dy dx equals 3 of the d squared y ds squared. Okay, minus 12y. Now I send everything from the right to the left. Okay, so I have d squared y ds squared minus 3 d squared y ds squared. Okay, then plus 2 dy dx, then plus 12y is equal to 0. Now let me represent the derivatives by just y prime and the rest. So I have 1 of the d squared y ds squared, and I have minus 3 of that. So when I subtract, I get minus 2 d squared y ds squared, and that's the same as y prime. Okay, plus 2y prime plus 12. Okay, I'm writing it because it wouldn't go here. Plus 12y is equal to 0. So if I divide through by negative 2, we'll then get y prime minus y prime. Okay, that is dy ds minus 6y is equal to 0. And this becomes our required differential equation. Very simple. Or somebody can write this: d squared y ds squared minus dy dx minus 6y is equal to 0. Anyhow you want to write it. Okay, now let's move on to the last one, and I'll give you a trial question to go and solve for me. Okay, so I have eliminate the constant c from the equation. So having this equation, if I give you only this equation and ask you to eliminate this, I'm not sure you'll be able to eliminate without any other information. So what this question is trying to tell you is that you should find the corresponding differential equation with this general solution. Okay, so what will happen is that you check the number of constants here. We have only c is a constant. Okay, so you have c here and you have c here, and c is the only constant here. Okay, so what will happen is that in order to solve this, you just need to differentiate the whole of this equation by 1. Okay, and I'll have, when I differentiate the whole of this side, only s minus c all squared to the power, all squared with respect to s, I'll have 2 into the differential of the bracket, and we have x minus c. When you differentiate that with respect to x, you get 1, so I just don't write it. Okay, then I have the same bracket back, but this time subtract 1 from the power, so I have x minus c. Now plus the differential of y with respect to y squared with respect to x, and you use chain rule here, so I have 2y dy dx. Okay, 2y dy dx and this equal to 0, because when differentiate c, where c is a constant, so you get 0. Now I expand this and I have 2x minus 2c plus 2y y prime, because dy dx is the same as y prime. So if I divide through by 2, I have x minus c plus 2y y prime is equal to 0. And obviously this is non-linear differential equation. Okay, I hope you can see this. So I have x minus c plus what, 2y y prime equals 0. I think, yeah, divided through by 2, so here this 2 should go. I hope I'm doing the correct thing. So I'll have my c to be equal to what? So if I send c to the right side of the equation, I'll have x plus y prime, okay, should be equal to c. So in all, c is equal to x plus y prime, which is dy dx. Okay, so you go back to your first equation, equation 1. Okay, this is our equation 1. Let me put it that way. And after differentiating, this becomes a equation 2. And I hope you remember that when we say that if you have one constant, you need 2 equations to eliminate it, and that the differential equation should be of order 1. Okay. Now the first equation, we have, the equation is what? X minus c all squared plus y squared equals c squared. So now that I have c, what I do is I put c in place of wherever I see c in the first equation. So x minus c, and c is x, this one. Okay, c is the whole of this, so minus of everything become minus s minus y dy dx all squared plus y squared is equal to c squared, which is x plus y dy dx all squared. Okay, so if you simplify this correctly, okay, I won't go through the simplification, but you can expand everything. I mean, this can cancel this, so you have only minus y this, so you have y squared, because minus y squared is the same as this y squared, so dy dx all squared. Note this, that this is not the same as d squared y dx squared, plus y squared is equal to s squared, okay, plus 2xy, then plus 2xy dy dx, okay, then plus dy dx all squared. Okay, so if you simplify, like I've already simplified this, so you can group like terms, and when you group like terms and do everything, you have y squared minus 2xy dy dx minus s squared is equal to 0 to be your differential equations. Okay, very, very simple like that. So some people would simply write it like this: y squared minus 2xy y prime minus s squared, okay, is equal to 0, and there is a differential equation. Or in all, we've been able to eliminate the constant c. Okay, now these are your trial works. So first of all, you have this as your general solution. Okay, the question 1, you have cxy plus c squared x plus 4 as your general solution, and your task here is to find the differential equation corresponding to this, and there is a solution: s cubed dy dx all squared plus s squared y dy dx plus 4. And here you should know that since we have only one constant c, the higher order derivative should be just dy dx. That's the first derivative. Okay, it should be a first order derivative, and that you need only 2 equations, this equation being 1 and then the first derivative. Now the second question is this: I have something like this, an ellipse. Okay, So and its corresponding solution is this one as well. Okay, so you go through it. We have two. How many constants? You have A and B. So you need what? 3 equations, and your answer should be, or your differential equation should be a second order derivative. Okay, I hope you understand this. So this is your answer as well. And then with the third one, I have s squared plus the bracket y minus a squared equals a squared. This I've solved a similar one. Okay, this is obviously the same as the question 4. Eliminate the constancy. Is the same thing, just that this time around we have the constant appearing at the y part. Okay, and we are saying that the solution is this. So you can go through it and kindly make sure that you have these corresponding answers as your answer. And when you are done with it, just come into the comment section, comment and tell me that you've been able to do or not. Thank you, and don't forget to subscribe to my channel. See you next time.